So I recently did an experiment comparing the types of dirt on my right and on my left. And my experiment was to get a single seed and plant two different flowers. And because this single flower is much bigger than that small flower over there, that dirt is obviously much better than the other dirt. Wait, I'm wrong.
Yet what Spencer doesn't understand is that he needs a large sample size when running an experiment. Because, say that flower over there didn't grow tall enough, it could have been a bad seed, there could have been different fertilizers on each side of the grass. So the correct way to run this experiment would be to have a larger sample size and plant many seeds of the same kind.
I'm doing a sample survey to figure out which color car is most popular with high school students. So how I did this is I walked up to a random group of 3 cars and they're all green. So that means every single car that any Duxbury High School student drives is a green car because my sample of 3 cars are all green.
What Spencer doesn't understand is that he did not perform a simple random sample correctly. You can't just walk up to 3 cars and pick this one, and that one.
What is a simple random sample?
A better way to perform this sample would be to write down all of the different parking lot numbers on a single piece of paper and pulling random 3 ones out of a hat. That way, you don't have cars that are all right next to each other. I could have a blue car down there or a red car down there. And for my experiment, I've created a different formula of Gatorade that would make baseball and softball runners run super fast around the field. I gave this drink to Riley, and he's about to test it out. Riley?
Yeah.
Well, although he was running the wrong way, he still ran super fast, which means that my formula worked and my experiment was successful.
Yeah.
What Sarah doesn't know is that she needs something called a control group. That means for this experiment, she would need Riley to run across the field without drinking the Gatorade and see how fast he ran, and then give him the Gatorade and see if he ran any faster with it or if he ran slower.
One of the most common types of survey errors is called wording bias. In this, the writer has made one answer seem more favorable than others. In this example, dogs seems more favorable than cats because cats is presented negatively. This is a more appropriate way of presenting your survey question. Not because it's more simple, but because both questions are equal.
Hey, do you want to take this survey?
Nope.
Are you sure?
Positive.
If people choose not to answer your survey, it is likely that they do not have strong feelings towards your subject. And if they do answer your survey, it is likely that they do have strong feelings towards your subject. The fact that you're only getting a certain amount of people that all have the same strong feelings could affect the results of your survey. This is called non-response bias. Say you survey 20 girls in the 7th grade, and you ask them the question, what do you like better, softball and lacrosse? Say 15 out of 20 say that they like lacrosse over softball. You can't make the inference that most of the 7th grade likes lacrosse over softball because the grade consists of both boys and girls, and you only surveyed girls. This survey error is called population inference. However, you can make the inference that the girls in the 7th grade prefer lacrosse to softball because you sampled.
If you give a survey to the first 20 students that walk into DMS on Monday, you're making a big survey error. Say your survey question is, do you feel rushed to get to class on time in the morning? The first students who walk into school are more likely to say no, because they are early and have plenty of time. You're missing a large portion of the population, the students who are running in the door right before the bell rings, all of which would feel rushed in the morning. This is called convenience bias.